Hey everyone, welcome back to another episode of Blueprint. My name is Nikzad and this is the second session of TouchDesigner Beginner Workshop. Today we want to first shed more light on channel operator, also known as chops family, and then we will have a brief introduction to 3D rendering and building an interactive network inside of TouchDesigner. Also, we will talk about how you can set up your rendering system by adding a camera, geometry, light and materials to your scene. And finally, how we can interact with all the different parameters to make a real-time or live 3D scene. Okay, let's get started. You can now open TouchDesigner, and as always, you can press the Tab key on your keyboard to bring the operator window, or you can also just double click on the network editor to open this window like this. Okay, let's first have an overview on chops family here. Chops are dealing with all kind of data or signal, anything that got to do with data analysis, signal processing, or audio happening in chops. Any device that you want to connect for receiving or sending signals. Devices like Kinect, Leap Motion, MIDI devices like MIDI keyboard, MIDI controller, DMX devices for sending out DMX data, or I don't know, when you want to control laser modules or serial devices. Also, you can use chops to control any sort of hardware or software that supports OSC or UDP controls. And what else? Yeah, also chops are useful when you want to make a connection or sending or receiving information, cues or MIDI between TouchDesigner and Ableton. Also for generating time-based animation like keyframing when you're dealing with the time-based composition. I think also they are super handy when you're dealing with any sort of data calibration. For instance, when you're using some sort of sensor that is noisy or it's not that accurate, and you want to filter or kind of normalize the input to have more usable data. Also, when you want to using motion capture, mocap devices, and you want to isolate some specific movements or something you want, sometimes you want to make a limitation of the area that you want to track the movement and cut the rest of the data. You can use chops to analyze and control the signal flow for having more accurate control of your interactive system. And I think you can also control any sort of parameters when you're working with chops. You can control movie player or kind of animating image effects or camera movement or light intensities, yeah, this kind of stuff. Okay, let me give you some example. For instance, let's get started with DMX. TouchDesigner supports DMX-based protocols, DMX ArtNet and SACN. And you can simply use DMX out chop, like this one, to send out DMX channels to any devices that support DMX protocols, such as lights, fog machine, or sometimes system controllers. DMX chops comes with this menu here, interface, that you can easily choose your interface. DMX chops support NTEC device when you want to send the channel through DMX or XLR cable, and also it supports ArtNet DMX 512A protocol over UDP. Super handy when you want to send out channels over a local area network such as Ethernet, and especially when you're dealing with a massive number of channels or any situation that you want to sending more than a single universe or more than 512 channels. And also ArtNet supports up to 32,700 something universe over one piece of Cat5 cable compared to a single universe over a DMX or XLR cable. Yeah, that's its advantage. Or you can use SACN if you want to, this one. I think the difference between SACN is, I think SACN is, I'm not sure, but I think SACN is also a DMX protocol. But the difference is when you want to send channels over IP network using UDP protocol. And I believe unlike DMX over XLR cable with up to 256 channels, universes, sorry, SACN allows you to send out something around 64,000 universes. Yeah, that's too many universes. Let's move on to another chop and delete this one. Okay, audio. TouchDesigner supports AGIO, direct sound, and dental. Let's look at the audio file in chop. Audio file in chop. With the audio file in chop, you can easily import audio files, and it also supports MP3 and WAV. You can also change the speed, make a cue point, and press the cue pulse to start the file from that specific cue point. Also, you can trim. Also, you can trim the file if you want by just toggle on this trim, and then you can trim the file, or turn on or off the repeat from here. Yeah, of course you can hear any audio until you add audio device out. Audio device out. And let's back trim point, speed 1. Okay, cool. The audio device out sends the audio signal to any of the attached audio devices using direct sound. At the moment is just direct sound by default. Or if you connect the audio interface or sound card, you can using AGIO, this one. And then you can route each audio channels to a different speaker location by pressing on the second page, output 1 or output 2. So let's back to this one. Yeah. And now you can route all these channels to speakers if you located any speakers in the space. Yes. Also, you can use audio device in. Let's bring the audio device in. Like now, you can use the audio device in to receive audio from any plugged audio interface using direct sound again or AGIO. Cool. Let's get rid of this one. And now, okay, another useful chop is the audio movie chop. Let's bring the audio movie chop. The audio movie chop can play the audio of a movie file that is imported and playing back with the movie file in top. So let's movie file in here, and I believe this one has an audio here. Okay, then you can just easily drag and drop your movie file in to these parameters, movie file in top, and then you have this audio. Okay, let's move on. Also, You can export or save an audio stream to file by using audio file out chop. So back to the chops, audio file out. Connect this together. And then you can start press record. And audio file out also supports WAV MP3 and I believe AIFF. Okay, move on to environment scanner and tracking devices. TouchDesigner supports Microsoft Kinect 1, Kinect 2 and also Kinect Azure. So let's bring Kinect chop. Of course it complains that Kinect is reporting the device is not available. Of course, because I'm not connected any Kinect at the moment. Kinect chop reads positional and skeleton tracking data from the Kinect 1 and the Kinect 2 sensor. And you can choose the Kinect version from the hardware version here. Also, you can change the skeleton type, full or seated. I've never used the seated and I don't think it's that much accurate, but yeah, that's another subject for another session and maybe we can cover it later. You can also change the number of player up to 6 player when you're using Kinect version 2 here. And I think the maximum of player on Kinect version 1 is limited to 2 person, but I'm not sure. Okay, let's move on. Okay, another useful chop is the RealSense chop for RealSense Intel RealSense camera. RealSense chop fetches the tracking data from the Intel RealSense camera. And of course you need to first plug the camera, otherwise you always see this error here. And I believe the rest of the parameters are kind of similar to Kinect chop. Okay, let's move on. The other one is Z chop. The Z chop reads positional and plane tracking from Z camera. And Z camera are stereo depth cameras produced by Stereo Labs, I believe. There is also Z tops that capture video from Z depth camera. And also Z sub that used Z depth data to create geometry. Super interesting stuff. And also there is a super handy chops for lip motion sensor. Lip motion. Okay, cool. Lip motion chops reads hands and finger gesture data. Also, it can track lip motion tools position if you have the correct SDK. And of course, you can change your SDK or API from here, I believe. And sorry folks if I'm explaining all of these chops a bit fast, but the thing is, this one is more like an overview of chops input devices. I'm trying to just give you more example, and of course we can just cover them all in next episodes. And what else? I believe the list of devices goes on, and it's almost impossible to cover them in one session, but I think you just got the point. There is plenty of chops that supports input devices for interaction with the real world. Okay, that was one aspect of chops. Chops are powerful when you're dealing with data streamed from input devices. But the other feature of chops are generating signal or processing numeric data. There is plenty of different ways for generating numeric data inside of TouchDesigner. So let me start with some really simple example. The first one is the beat chop. BitChop generates a mixture of ramps, pulses, and contours based on BPM, beats per minute. On the first page, you can change the period of each ramp, this one. It's kind of change the speed, or pulses by changing the period. You can also multiply or add channels. And also you can just type down the amount of channels. You can generate full set of channels and make a delay for each of them relative to the period channels. And also you can add a random shift offset to randomly time shifted each ramp, again relative to the reference ramp. And also you can change a random seed to generate a different set of random offsets. I will explain all, don't worry. And on this output page, you can output sine waves instead of ramps. At the moment on ramps, you can just change it to sine waves. Or you can just change it to pulse or contours. And I believe contours just increase the count every each bar. Or you can output the bar if you want, or beat. Or also you can output all together. Yeah, super. Okay, move on. The other way for generating signals is LFO chop. LFO. LFO chop is a low frequency oscillator. It generates waves in real time. Yeah, on the first window you can just change the shape of or type of waveform. At the moment it's on sine. You can just change it to ramp, for instance. Obviously you can just pause it by toggle on and off. You can change the frequency to change the period of each cycle per seconds. You can add offset to the output channel, or you can scale down and up the output by changing the amplitude value. And finally, you can change the phase degree by changing the phase value. I'm not sure, but I believe a value of for instance 0.5 is 180 degree shift or half a cycle. Let's go to the channel. On the channel window, you can rename the channel name. One. Or you can add more channels by just type it down. Name 2 doesn't make sense, but you can do it. And what else? Yeah. LFO chop is super powerful chop, and I believe there are plenty of different features that I didn't explain. Things like you can control the oscillator by connecting a source. There are 3 input source here. Or octave control, or adding a source way and then manipulating the source. Yeah, there are plenty of different features, and I'm gonna explain them all. Okay, let's move on. The other useful chop for generating waves is noise chop. Noise chop generates a unique wave without repeating samples with a value range of -1 to 1. With the noise chop, you can generate waves or curves with different shapes. Again, same like a LFO. You can adjust the period, changing the amplitude, or changing the scale of output, or changing the harmonics, and more and more. I'm going to explain all. And let's go to the channel window, channel page, sorry. You can just, same like LFO, you can rename the channel name or add more channels. Gen 2, Gen 3. You can change the starting and ending point of the interval, and you can, let me just change it like this. And also you can change the units. At the moment on seconds, you can change it to frames, or you can just change it to samples. What else? Oh, again. And you can force the channels to be time slice by turning on the time slice. And now it shows the time between the last cook and the current cook frame. Super nice. Move on. Okay, folks, let me give you just 2 more examples, and then we can finish this part and move on to the 3D scene and rendering. As I said before, chops are powerful when it comes to processing signals or numeric data. So let's take a look at some of the useful chops for processing, manipulating, or editing the signal. Let's start with a simple one, limit chop. And let me also bring LFO again, and then connect these two together. Limit chop can limit the input value or input channel between a minimum or a maximum value or number. There are several different methods for limiting an input value, but let me just start with the clamp function, this one. By choosing the clamp function, you can set the minimum and maximum value and somehow make a limiter to rearrange the input signal. For instance, in this situation, we have an input signal that starts from -1 to 1. But for any sort of reason, we just want to use a range of something 0.2 to 0.5. So we can easily clamp the input by typing these numbers as a minimum and maximum value. And now if you look at it, the output is limited to this specific range. Super handy when you have an input signal from, for example, a distance sensor, and you just want to use or select the signal between a specific area or range and just ignore the rest. Very useful. And also there are different functions such as loop and zigzag here that we can discuss it later when we want to use the limit chop in our network. Great, move on. Last example, let me also introduce you to another great and useful chop, which is mass chop. Mass chop performs mathematical operation on a single channel or on a group of channels. So let me bring LFO as a single channel and bit as a group of channels. And I'm gonna multiply it to 3 to have 3 channels. So connect this one. Okay. So now you can just add or subtract or multiply or divide all of these channels together. So you need to just go to the mass, and now because these are channels, you can combine them. Add, subtract, multiply, just add. Or you can go to the multi-add, and then again, and also you can multiply a group of chops. So let me connect these two together, and now again I can combine chops because I have 2 chops. I can add them together. Yeah, cool. And now we can go to multi-add, and in the multi-add page you can pre-operate each sample by adding a value to the input signal or multiply it by a different value. You can just, for instance, pre-add 1 to all of these channels, or you can just multiply them to a number 2, and now you just multiply them all together 2. Or you can completely rearrange the value. Let me get rid of this one. On the range window, you can set the low and high range of the input signal and then rearrange or convert them to a new range. I know that this value is -1 from -1 to 1. So I can just easily say from which range, -1 to 1, and now I can just easily rearrange it to, I don't know, 10 to 21. Super handy. Or in the comment page in here, you can easily decide which of the input channels needs to get affected. In this way, you have full control over the operation. You can just select the first channel, or you can just select only some specific channel and ignore the rest if you just want to have this specific operation on any sort of a specific channels. So let me show you. So for instance, I just want to have this specific operation on a ramp number 2. So I can just select it, or I can just type it down here. Or you can round the floating number to integers. Back to op. Yes, here. There are 3 different methods to round or convert the input signals: scaling, floor, and round. Great. Yeah, the mashup is super powerful, and I think you should just take your time and use the wiki page to study all the different functions. And just as a reminder, you can always click on this question mark icon, and it just bring you to the wiki page for this specific chops. Okay, let's move on. Great. Also, you can look at the OP Snippets window on the help menu here and operate snippets. OPS snippets is a great source of many useful examples of all of these operators. You can copy paste them on your project, or you can study a different method of using different chops or tops or subs or mat or dats. Yeah, super handy. For instance, I can just click on bits, and now I can see one example of bits, and I can just copy paste it into my project, or just use it for study how bits chops works. And in general, I can say the chops are made to help you with programming, even if you don't have any knowledge of, for instance, C++ or hard coding. And since they are pretty much cover most of the fundamental tasks in programming, you can simply use them for expanding your network, or finally you can developing your piece of software without knowing any C++ or hard coding. And of course, if you know how to write C++, you can bring the game to the next level by using C++ chop. And of course, then you make your operator, or you can just writing your plugin using C++. Perfect. Great, let's move on. But before go any deeper, I need to say that setting up the camera, light, materials, and in general rendering patch or setup can be super simple and easy, only for sake of practicing some rendering methods or studying some specific materials. Or it can be super complex with a fancy approach for making a shiny animation or piece of art. And Same as all the 3D software, rendering your scene can be different from time to time based on your setup or your needs or your idea. So just as a reminder, what I'm going to explain in this part is just an overview on PBR rendering and how you can set up a simple PBR rendering setup. This is more like only an overview for folks who just started with TouchDesigner and need some cues on how they can use TouchDesigner. So please don't consider it as some sort of tutorial or think like this is the best way of setting your camera or dealing with 3D modeling or stuff like this, because I'm sure it's not. So please take your time, experiment with all of these parameters, study different types of materials, textures, camera setup or light, and kind of try to find some methods that are closer to your taste or your artistic approach. Okay, having said that, let's back to our network editor, and this time let's make something cool together. In general, every rendering setup inside of TouchDesigner has 5 components: camera, light, geometry, material, and finally the render top. So let's first bring them all inside of the editor, and then I will explain them all. Again, press the tab on your keyboard or just double click on the editor. Great. I'm going to start with light, and as you can see there are 3 types of light, but since we want to just try the PBR rendering, we need to bring the environment light and also a normal light. Environment light and just a normal light, because PBR material needs an environmental light. Then we need a camera, and of course we need the geometry, and then material. Again, there are a bunch of different materials inside of this matte family, but since I just want to use PBR, I'm going to choose PBR. And then of course we need a render top to see what's going on inside of our rendering pipeline. So we need to go to the top window and then render top. Okay, so far so good. Great. First, let me explain quickly what is PBR rendering. PBR stands for physically based rendering. It's a computer approach to mimic the way that how light flows and reflects or reacts with the 3D objects in a real life, or with the different types of surfaces. Usually, you can use the PBR pipeline to get some sort of photorealism renders or output from your scene, or sometimes just simulate real life materials. And to be honest, the PBR pipeline is a pretty damn complicated and at the same time amazing system. So I strongly suggest starting a study on the PBR pipeline if you've never used it. Having a better understanding on how the PBR pipeline works helps you a lot to control all the reflections on your scene, or control the light diffusion, or making a more accurate, transparent or translucent material. And I believe in general it helps you for having a better control over the roughness of the surface to have a more realistic result, instead of just making a shiny plasticky materials all the time, which is super nice but not all the time. Okay, let's back to our network. As you can see, there is an error on this environment light, and the reason is this light needs to read an environment map. Basically, the environment map can be any sort of 360-degree image or photo. And the reason is the PBR pipeline needs an image that covers the whole sphere around our scene and gives the light information to the material. Also, this maps gives indirect lighting to the material. So without this map, everything can be black or dull, since there is no any light reflection, because there is no environment light or information that gives all the light diffusion to our pipeline. So to solve this issue, you can easily download some 360-degree image from the internet to start with, or you can just add a movie file in, go to the top, movie file in, and import this cloudy ocean. And then after that, you need to click on the environment light and then drag and drop this movie file in to environment map parameter. Great. Now we need to assign our material to our geometry. So first, doing that, you need to bring this one here, drag and drop the material to the geo, and then press material. Great. Now we have a pretty much a dull surface, face, whatever, which is exactly what we want. Let's start with the material to understand what is going on inside of our pipeline. On the first page, RGB, you can see we can change our base color, specular level, metallic level, roughness level, ambient occlusion, and finally the environment light quality. So let's start with decreasing the roughness all the way down to have a completely glossy or reflective surface. You can see the PBR material reads the environment map, sends the ray into the environment map, and then samples the lighting reflection. That's great. But the thing is, at the moment, we're still playing with the foam texture, or in other words, we still don't have any texture designed for this PBR material. Okay, there are lots of different ways to design a texture for a PBR material inside of TouchDesigner. I'm going to cover at least one way today. The first one is using substance map. It's kind of easy to use, but you don't have that much control over it unless you start designing your substance texture by Substance Designer, and then you can do whatever you can imagine. So let's bring the substance top first, and then I will explain what is Substance Designer. Go to the top and then type substance and then bring it here. Adobe Substance Designer is a powerful node-based tool, kind of similar to TouchDesigner. It allows you to create a super nice texture that are able to be used in any program that supports bitmap image. Also, Substance Designer has a really interesting library that you can share your materials or download some cool materials. And this Substance Top is more like a tight integration between TouchDesigner and Substance Designer. This Substance Top also allows you to import your SPSAR files from Substance Designer into TouchDesigner, so you can use them with a PBR material. Super handy. So now, to get some nice substance material, we need to go to share.substance3d.com and download some cool example. Okay, now we need to go to the materials, and then you can just simply download your favorite material to start with the PBR pipeline. And of course, if you're already familiar with Substance Designer and you can design your texture or materials Then you can just simply export them as a SPA, SAR files and then import them into TouchDesigner. Since I already downloaded some cool materials, so I leave this part to you and then I will back to TouchDesigner. Okay, bringing the substance maps is super easy. You can just, let me bring mine. You can just drag and drop the file into TouchDesigner, or you can just import the file from here. Great. So now we have our substance material in here. The only thing we need to do is just to assign our substance material into our PBR material. So if you click on the PBR materials, then you can see on the second page, maps, there is a substance top parameters. So you can just simply drag and drop this substance material into the substance top to assign this PBR, assign it as a PBR texture. And let's delete this one and take a look at our result. Kind of already nice, but let's dive a bit deeper. Let's first start bump up the resolution of this texture, the substance, by going to the common page and then resolution. So you can just multiply it by 4 and then let's check it again. Yeah, much better. Or you can just multiply it by 8. Anyway, if it's too heavy on your GPU, you can just multiply it by 2 or 4. And don't remember that every time when you import a substance map, if it looks like a bit hazy and you feel like, okay, it's a low quality texture, it's not. You just need to first set the resolution to something usable, like 1024 by 1024. Now let's check the input value from this substance here. These are the custom parameters that are built inside of Substance Designer, meaning that these are the custom parameters that the author created in Substance Designer and then exported with this file. And when you import this file, you can just change or adjust all of these parameters. For sure, these are not always the same and they are different from file to file, but after a while, you can find the logic behind them. Now start just playing with all of these parameters to, I don't know, make it a bit more better. And don't forget that these parameters are created by Substance SDK and you cannot animate them. And this is why when you changing some of these materials or parameters, it takes a bit of time to compute itself again. So you can adjust them, but unfortunately you cannot animate them in real time. So I'm gonna start with the normal intensity, high range, high level, and a bit metal roughness. And also you can just change this random sit. Okay, great. Let's now take a look at the different way that we can play with this material. So again, click on the PBR material and then go to the RGB page. And now you can just adjust the roughness and metallic from here. So let's click on this one and then you can see, yeah, that's much better. PBR, and now we can change the roughness, we can change the metallic, we can change the ambient occlusion, and I think maybe something like this is kind of okay. Okay, there is also another way to edit our substance material, is to kind of ungroup the substance file and then edit each of them by tops. For doing that, we need to bring the substance select top, and then assign this one in the substance top parameters. And now we can access to all of these different let's say image. I'm gonna start with the base color, and now I can just easily bring, for instance, HSV adjust, connect these two together, and now I can just change the color or hue like this. And when I'm done editing this one, I can just back to PBR, go to the maps, and then overwrite this new one. And let me just add a null at the end of this chain, and then assign this one by overriding the base color map again. And of course you can do the same with all of these image, base color, ambient occlusion, normal. You can edit them all. And the advantage of this method is now we can interacting with all of these with tops parameters. And since the top family works on GPU, we can animating or interacting with most of these parameters without being too much worried about the performance of our patch. Something that I will cover in the next part. Now let's play with our light setup. Let's start with our environment light. Here you can, in the first page light, you can change the light color from here. Yeah, of course I'll stick with this one. You can change the intensity by changing the dimmer. Let's change it to 1.5, 2. For sure, you can change your environment map or the 360-degree image and change the whole lighting setup. And also you can just rotate the environment map image on the X and Y axis from here. Great. Let's move on to our main light and go to this light page. Again, you can simply change the light color. You can change the dimmer. I'm going to change the dimmer to 2. You can change the light type. Let's change it to cone light. And then of course you can just change the cone angle, cone delta, and cone roll-off here. And also you can go to X form and move or rotate your light source through space, or you can just yeah, let's do it from here, it's easier. No, too much. Yes. Something like this. And also the other thing is you can go to the pre-X form and toggle on this apply pre-transform and fine-tune your position if you want to. Yeah, you can easily just play with all of these things. I'm not gonna explain all of them, but yeah, it's pretty simple. Rotate, translate, X, Y, Z, and you can also change the order from X, Y, Z to something else. Okay, now let's go to the shadow page. By default, the shadow page is off. You can just choose hard shadow or soft shadow. Let's go to the soft shadow. You can change the resolution to refine the shadow resolution, and also you can change the filter samples to make your shadow resolution much better. But remember, The shadow is quite heavy on your GPU, so please just go easy with it. And I'm gonna just multiply this one by 2 and this one by 2. Great. Okay, now let's back to our PBR material, this one, and then go to the rim page. As far as I know, the rim light is kind of similar to rim lighting technique in photography. It puts the light around the edge of the subject. So let's test it with this setup. First, you need to enable it, and then you can use a texture like a noise top to multiply the rim light color. It's kind of similar to lighting map or projector mask. It's multiply the calculated rim color onto the surface. So let's do it. Let's bring in noise. Put it here. Then use it as a rim color map. Yeah, you can just change the period and see the effects directly on this surface. What else? You can change the rim color. It's more like a light of the color of light. Let's go for something like this. With the rim center, you can change the light location. So it's more like this. With the rim width, you can change the distance between the light source and the subject. And of course, with this one, it's more like a dimmer. You can just increase or decrease the light intensity. And the nice things about this rim light is you can add more rim sources to the scene by just simply click on this and then enable the second light. Rim center. It's too much. Yep, cool. Or you can just simply delete it if you want. Yeah, I'm gonna delete it. Okay, great. Let's take a look at our camera setup. This one. Same as the light, you can move your camera through space by just translate the parameters or rotate it. So on the X form page, you can just rotate the camera up and down, left and right. And also on the pre-X form, you can fine tune it. First, you need to apply pre-transform, and then you can rotate it like this. Something like this. Okay, great. Now, if you go to the view page here, now you can change the projection view from here, projection, and you can change it from perspective, at the moment it's perspective, to orthographic. And if you change it to orthographic, then you have ortho with instead of FOV. So let's do it. Yeah, great. Now let's back to the perspective. And then we can control the FOV angle here, field of view. FOV calculates in X and Y, horizontal and vertical FOV. But also, you can change the viewing angle to focal length and aperture. So let's do it. And then you can of course, easily set up your focal length and aperture. Great. This near and far changing the position of the clipping plane and visibilities. So let's play with the near, and then you can see it's kind of change this visibility plane through a space. Let's bring it back here. Now, this window roles defines the center of the window during the rendering process. It's more like a panning camera without actually moving the camera. So you can kind of consider it as the panning movements, and you can also pan it on the X and Y axis. Oh, sorry, this one. And the window size, yeah, you can still consider it as a zoom. And window roll, you can, yeah, again, consider it as a rolling camera. Yeah. Great. So let's take a look at the Geo Setup Geometry. Again, you have all full control over the position of the geo in the space with the X form and the pre-X form. I'm not gonna explain it, it's kind of same. And also you can move or animate all of these parameters. You have a 2-page with all of these parameters. When you want to use, for instance, all these chops, you can export all these chops to these parameters and make animation. I'm gonna do it in the next part. And then you have these two instances or instance pages when you want to start playing with the instancing techniques. I think I'm not gonna cover it today, but maybe on the next episode we can discuss on the instance techniques. It's super nice. But now I'm just skip these two parts. And finally, our last piece of this small render setup is the render chop. This one. The render chop is used to render out all of these objects in your 3D scene. And as you can see, it needs a camera, light, geo, and material to work. The render chop is able to render multiple cameras, lights, and geo. And you can just simply assign all of these components inside of this render page. You can add more camera or light or geo to the scene and decide which one you want to render just by typing down the name of each component here. You can assign which camera, which geo, which light, or you can just simply say all the lights, all the geos, and all the camera. You can change your projection or render mode to render your scene in a normal 2D mode. At the moment it's just a 2D mode, or you can just render it as a cube map, which renders 6 views, and you can just use it to make a 360-degree output or environment map. Or you can just easily change it to something like fisheye. Fisheye renders your scene in 180 degrees. And also this one, you can just simply render your scene as a UV unwrap, which projects the 3D model texture into a 2D texture, I believe. And the advanced, I will skip the advanced page and GLS for now, so let's look at the common page. On the common page, you can change the true resolution of the output texture here. But don't forget the non-commercial key is limited to 1280 by 1280. So if you want to render your scene in a high resolution, I believe you need to order the commercial or educational key. And also you can change the output pixel format here. 8-bit, 32 bits, and so on. Okay, great. Okay, folks. Now we have a nice basic rendering setup. Let's start tweaking our output, and then we can animate in some of these parameters. So let's first back to the render page and change the render mode to 2D. Now, great. And now go to the PBR, and you can go to the RGB, and maybe I'm gonna just change my base color to, I don't know, something like different color, maybe, yeah, something like this. And then I can go to my HSV adjust and also change it like something like this. Come back to my PBR and then go to the rim light and change my rim color to was kind of, yeah, I think it's nice. My rim center and a bit less. Okay, great. And okay, and also let's bump up the normal map and this one to add more texture to the surface. I'm gonna change it maybe to something 20. Yeah, it's great. It's too much, but it's nice. I like it. The other super nice feature of the PBR material is this Parallax Scale. So Parallax amplifies the value that is applied to the height map, but you need to first enable the height mapping. So let's enable it, and then you need to enable the parallax and these two, and then you can start playing with the display scale and display midpoint. Something like this. Back to Geo form, rotate it. Yeah, now it's too much. Okay, it's kind of nice. Let me back to my camera. Where's my camera? Here. And render setting, no, view, sorry. And maybe I'm gonna just, oh, I'm gonna just zoom a bit. And yeah, great. So now we can start animating some of these parameters, because now it looks nice but is boring. So let's do it. There are plenty of different ways of interacting with each of these parameters, but I'm going to start with something simple and make a really simple animation. So let's add the constant chop and the speed chop to the network. Constant chop here, and then speed chop. Connect them together, and then go to the constant chop, and on the first channel just change it to something like 1, and then speed chop. Okay, a speed chop converts speed to distance over time. You can feed it with a value or rate. In this example, I just feed it with this constant chop, and it just outputs an increasing value of this specific channel. So, okay, now another way, we can also add LFO chop, LFO, and then we can rearrange this value by mass chop, connected together. And since I know that this value is from -1 to 1, I can easily go to this range page, type -1 to 1, and then rearrange it to, because I'm gonna use it to rotate this object, I'm gonna just rearrange it to 0 to 360. Great. Now we can also bring the noise chop go to the channel, start 0 to 10. Yeah, it's great. And I'm gonna time slice it. I need to go to the noise, and maybe I'm gonna just change the period to something really small to make it like a really fast number. And again, I can also bring a mass chop again here to multiply it. This time I'm gonna just multiply it to 10. So now also I'm gonna bring null to use at the end of all this chain, multiply it 3 times, 2 times. Okay, now we can start using all these data to animating some of our parameters. So let's start with this geo. I can go to the pre-X form and use my first one, null number 2, to animate, for instance, rotate. And the nice thing about speed chop is I can easily just change this constant chop. I can change the channel 1 to something a bit higher, and at the same time I'm going to change the speed. Cool. So the other one is we can use the second one for y-axis, and we can go to LFO and just change our frequency because it's too fast. Yep. And then we can go to our camera setup and just, I'm gonna just reset these two. Okay, nice. And then I'm gonna use this noise for something like, maybe I'm gonna use it for this light. It's kind of nice. I can use this value to make this light flickers. So I will go to the light and export this channel to the dimmer. Yes, nice. And also I can now start playing with my cone angle. Yeah, something like this. And yeah, we can play with all of these things. And I'm gonna just add a transform at the end of this chain and change the background color, the alpha, to 1. And nothing like that. Yeah. Okay, nice. Yeah, great. It looks, I think it looks much better. Yeah, of course, you can play with all of these parameters to, yeah, first study each of them and also making the results that you are really looking for. And also, it's worth mentioning that, of course, this is a really simple setup, and you can easily just duplicate or add more lights and start practicing with more complex lighting techniques. For example, you can just add a fill lights, backlights, side lights to your scene, experimenting with all the different light colors and intensity. You can also animate all these parameters with chops to make a more like an audio reactive system. You can add as many geos as you want, or even a group of 3D objects, and then texturing each of one of them with a different type of materials. And the good thing is TouchDesigner supports FBX and USD file, so you can import your 3D scene with an animation from your preferred 3D software such as 3D Max, Blender, or Maya, or any software that supports FBX file. Also, you can, instead of using substance material, you can easily making your material in 3D software and then exporting the base, color, normal height, and roughness as a JPG or TIFF, and then you can easily import them using the movie file tab and assign them to the your material. And also, you can just add more camera to the scene, keyframing their movement with chops and kind of change your perspective. And also, don't forget that most of these nice effects start after the render top, so after this one. So you can just simply start color correcting, making your unique effects and adding them to your network, and then more and more. Yeah, great. And folks, I think this is it. I hope you like this episode. In the next episode, we'll discuss more interaction techniques, and also I will cover some of the nice subs, because we didn't talk about subs yet. And as a final part of these episodes, we can make a really simple user interface to have better control on our patch. And yeah, I think this is it. So wish you a great summer, guys, and happy coding. Thank you. Bye bye.